Good day, grade 12 learners. Welcome to today's Technical Mathematics Paper 2 lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Now today we're going to be looking at Paper 2, exam revision. So we're going to look at all the topics. The topics and their weightings. In paper 2 we have 4 topics with I think about 11 questions. So the first topic is the analytical geometry, which has plus minus 25 marks. We have the trigonometry, which has about 50 plus minus 3 marks. Then we also have the Euclidean geometry, which also have about 40 plus marks, 40 plus minus 3 marks. We have the circus angle and angular movement with measurement. So the circus angles and angular movement is about 20 marks. And the measurement is about 15 marks. So the 2 there gives us about 35 marks. So the total for that paper will be 150 marks. Now, first thing that you need to do, remember yesterday we talked about your exam preparation, where you must have your pen, your pencil, your ruler, your calculator and all that. Still have that when you write your paper 2. The information sheet is very, very important. So when you take your question paper, first thing that you need to do is to go to your formula sheet. In your formula sheet, you first identify the formula that you're going to be using, but you must do it today before you write it on Monday, so that then you know those formula that you are going to be using for paper 2. Your formula sheet, it's divided like this. So in other words, you're going to have your distance formula, which you must know. Take your formula sheet and now write down those formula. Which formula is for what? So the first one, the D, the one with the D stands for the distance formula. The one with the capital letter M is the midpoint formula. So you must use it like this. The one with the small letter m, it's your gradient formula. The m equals to tan theta is for your angle, which is the angle which is formed between. So this one you're only going to use it when you have the angle that is formed between the x-axis and the straight line. So the angle that is formed there, this is what we're going to be using. This is the formula that we're going to be using. If I've got a theta there, that's the formula that I'm going to use. The other formula is for the ellipse. Very important. How do I get the x value when I'm given this? So the x value there, I'm going to take the square root of this. So if I need the x value or the x-intercept of that ellipse graph, I must get the square root of the a squared. If I need the y value of that, I need to find the square root of the b squared. Okay, so make sure that the right hand side will always be equals to 1. Now this is the analytical geometry part. So in analytical geometry, these are the formula that we're going to be using. Right. The other formula that we're going to be using in analytical geometry obviously will be the equation of the straight line. Y equals to mx plus c, or y equals to y minus y1 equals to m open bracket x minus x1. So we need to also look at that formula. The trigonometry one, we're going to use the sine rule. Please, the sine rule, we only use 2 at a time. Okay, don't use all 3. Okay, we use 2 at a time. Right, the area rule, when asked, when do I use this? When I'm asked to calculate the area When I use the sine rule, when I've got two sides and one angle which is associated with one of the sides. When do I use the cosine rule? When I have something like this, two sides given, side 1, side 2, and the angle must be included. So I must have two sides given and an included angle, then I can get the other side. So this one I can be able to get. Okay, so the cosine rule is written like this. Then we have a squared equals to b squared. That is when we're talking in any triangle. So I've got triangle ABC, which is not necessarily the right angled triangle. So where I have triangle ABC, so the small letter a will be there, the small letter b there, opposite that, and a small letter c there. So if I've got b squared or a squared, then it must be the a squared and equals to the b squared plus c squared minus 2 times this, b times c, and the angle must be angle A. Can you see? This side must be given, that side must be given, the angle must be given. That's when I use the cosine rule. Area rule, I said when asked, if I'm given the area and then I need to find the other side, I can do that. If I'm given this two sides, that must also be used when the angle has been included. Okay. The identities, this is a very, very important identity. Sine squared theta plus cos squared theta, so there's a theta there. Sine squared theta plus cos squared theta will always give us 1. We call it the famous one. So the one which is the famous, which is very famous in trigonometry, is the sine squared theta plus cos squared theta. It's equals to 1. That one also, 1 plus tan squared theta equals to sec squared of theta. Please, please, please know these identities because we ask them in an exam. So sometimes we just change something there and then we just take the 1 to that other side and we say sec squared of theta minus 1, give us the answer. So the answer there will be tan squared of theta. Okay, if I take for instance this one and put it on the other side, then I say what is cos squared theta minus 1, then the answer will be cos squared of theta. So we play around with them, and this one also we like it very much. We say 1 minus cos squared theta, and that will be equals to sine squared of theta. So make sure that you understand how to play around with those identities. Okay. Then we have the circles, angles, and angular movement. Very important topic also. Topic that we have done in grade 11. So there we have pi times radius, it's equals to 180 degrees. So if I want to change these degrees to radians, I'll say radian will be equals to the 180 degrees divided by pi. You see? So therefore I can be able to change that degrees to a radian. Now you must know those, how to change the degrees to radians and radians to degrees. So if I want to change the radians to degrees, obviously then it will be pi over 180. Okay, so now the angular velocity, very important. The sign there, this sign is an omega sign, we call it omega. You say omega, it's equals to 2 pi n. So the n there represents, you see, with the formula here, it's very, 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 this formula in the circles, angles, and angular movement, they are very easy because now everything is explained to you. What does the n stands for? It's rotational frequency. So in other words, in my question, I must look for that. If I'm given the rotational frequency, I immediately know that that will be n. Circumferential velocity, we have pi dn. So it's also explained that the d stands for the diameter. So in other words, if I'm given the radius, I'm able to know that the radius will be the diameter will be twice the radius. So twice the radius will be equal to the diameter. N stands for rotational frequency. Again, the n there is explained. The arc length, S stands for the arc length. So the arc length means if I've got something like this, that part here, that circular part there is called the arc length. So the arc length is equals to the radius multiplied by the degrees, but the degrees here, the degrees must be in radians. So meaning that if I'm given 15 degrees, I must be able to change it and make it radians. Okay, so I must be able to change it to make it a radian. So I've got a degrees, I must change it to be a radian. Okay, so the pi radians here, so the pi radians here will be equal to 180 degrees. So if I want to change it, I'll show you when we come to the question how we change the radians to degrees and how we change the degrees to radians. Okay, now we've got a formula for that. So remember, if I've got a 60 degrees, how do I change the 60? So it will be 60 multiplied by pi over 180 degrees. Therefore, it gives me the radians. If I need to change the radians to degrees, then I'll say 180 degrees divided by pi. So I'll show you when we do the questions there. All right, now the other formula, the area of that. So remember, I can use this, but when do I use this? I use this when I'm given the arc length. So if I'm not given the arc length, I cannot use this formula. So if I don't know what is the arc length, there's no way I can use this formula. Okay, the R stands for the radius. Now, the theta is the central angle in radians. Remember, in secant angles and angular movement, we are using radians. So mostly you find that we are always using radians there. So the radian there will be the central angle. In other words, if I've got something like this, and then I've got that, and I need the area of this part. So I need the radius, and I also need the central angle. But that central angles must be in radians. Okay. The last formula there will be, the last but one formula will be the angle, so the formula where we need to calculate the height of the segment, or we want to calculate the diameter, or we want to calculate the length of the chord. So if I want to calculate the length of the chord, and that's the formula that we are going to be using now. Okay, right, so H will be for the height of the segment, D will be the diameter of the circle, X will be the length of the chord. So everything there is explained, so you are able to see that that is explained. So there is no problem with this formula because this formula have been explained, so we must always be checking what has been given there. Okay, right. The formula, the formula for the measurement and the area. So in this case, we are only given the area. Remember, in measurement, where you do measurement, those formula will be given in the questions because there are so many formula. I mean, we can't keep all this formula here for measurement. You know, the surface area of a cube, the surface area of all those ones, you know, of a sphere and all that. So we cannot put them all here. So that's why the formula, you get them in the question. In the question, we put 3 or 4 formula, then you must be able to manipulate them and know how to use them. So here we only put the formula for the area of this area here that we're going to talk about when we do the questions now. So you see that this formula and that formula work almost the same. But remember, in this formula here, it is now written that the A is the equal parts. So in other words, mostly you find that the equal parts have been given, but sometimes they give you a long line and with its measurement. And you need to understand that it must be divided into the parts. You see when we do the question there also. The M1 and M2 and all that are the 2 parts which are O1 and O2 divided by 2. So you see also when we do that question at the end. N is the number of ordinates that we are going to have. For instance, we've got number of ordinates that we're going to have. We'll have to use the exact number of ordinates that has been given. Okay. Area there, we're using O1 plus ON, so in other words, it's O1 plus the last one, the first one plus the last one divided by 2. But then here, most mistakes that we do, we also have O1 here, we make it O1, and we don't copy the formula correctly, and we make a lot of mistakes. Okay, so when you do this question, I'll explain it further. Right. How do I achieve 30%? But I don't like this. I want us to achieve 40% plus. Well, the 30%, if we aim for 30, then you get 29 or 28. So let's aim for 40. So we aim for 40. How do I then get up to 40 marks? This was just a strategy on how we get 40 marks. So remember, your paid mark must be around 80% and more. Okay, so make sure that you are very serious with your paid. Now coming to the paper here, we're saying the algebra is 50 marks, and we are saying 22 marks will be the targeted. But I'm just saying 22 marks out of 50 is very little. The algebra that you have done there, it must be more. But now today, let's concentrate on paper 2 now. We say in analytical geometry, we have 25 marks. The target is 20, that's fine for me. In other words, you must always make sure when you're practicing, you look for that 20 marks in analytical geometry. If you practice two or three question papers, then you understand how the question papers are set and how to can get up to 20 marks in analytical geometry. In trigonometry, 12 is a very low mark. Let's aim for 20, and then when we do these questions, we'll check how can we then get up to 20 marks in our trigonometry, especially with the definitions, with the identities and the reduction formula and the equations. We're able to can get up to 20 marks here. If you're in geometry, we've got 40 marks. Let's aim for 20, so we can still get 20 here out of the Euclidean geometry, and I'll show you how, so that then you understand. So one of the things that you must always be able to do is to check your examination guidelines for the reasons, acceptable reasons in Euclidean geometry. So go and get your examination guideline and use the examination guideline to check what are the acceptable reasons and how do I write the reasons. Okay, I think that is one of the issues here that makes this life very, very difficult in terms of that. Still also grade 11 circle geometry and also grade 12. You know, the proportion is now becoming very easy. So we really need to look at the proportion and see how best can we get full marks from them. The measurement and the circles, angles, and angular movement is 35 marks. 11 is also very, let's up it to 15 marks. So if you check the total here, we'll get 20, 20, 20, 60. 60 plus that will be 75 out of 150, and we are all good. We are at 50% at least. So when you're practicing, make sure that in each and every topic that I've talked about here, you get the minimum that now we are discussing now. Make sure that today I'm practicing analytical geometry. Let me see if I can get 20 marks. Then you work it out, and then you get 20 marks. You're good to go. Trigonometry, 20 marks out of 30, you're good to go. So in that way, if I take an hour, for instance, an hour and a half, and I go to analytical geometry and try to get 20. Trigonometry, try to get 20. 1.5 hours in your question paper, you are almost done with it. So the next 1.5 hours that you're going to use, then you're trying to remember some of the things that you have forgotten here in all these topics. Then you then improve your symbol. From 50 you can still get to 70. Still you can get to 80% and up to 100%. So let's work hard on that. Right. Okay, let's now get to the values, to the questions, and try to get solutions to these questions. Right now, the first activity here. Now it talks to analytical geometry, which is plus minus 25 marks. I did not put marks in here, right? But let's look at this question. In the diagram view, it is very, very important for you, my boys and girls, to read the question, to read the statement that has been given, so that you check if it agrees with the diagram that is on the side. Okay. In the diagram, it is said that ABCD is a parallelogram. Oh, already I know that this is a parallelogram. Then I ask myself, what do I know about parallelogram? Opposite sides are equal and parallel. In other words, this side here and that side, they are parallel and they're also equal. This side here and that side, they are equal and are also parallel. So I already know that. You see, so what do I know about parallel lines? If this line is parallel to that, their gradients are the same. What do I know? The gradient of that line and the gradient of that line are the same. If I don't have the gradient of this line, but I have the gradient of that line, I can still get it, because if I get this one, then I get that gradient. Understand? So these are things that you ask yourself about. Why did they say this is a parallelogram? The next thing there is your A value, your B value, your C, your D. Check if those coordinates are correct on there. So the A value is 0,4. That's correct. My B value is 70. My C value is 6 minus 4. The D value is minus 10. And I can see they are correctly placed. Now the first question, the theta is an inclination. So I know inclination. There. It is the angle between the x-axis and the line. You see? Right. So now I have the questions. Now, the first question here, this was supposed to be the third question, but we can do that third question also here. Now, the coordinates of P. Let's look at the coordinates of P. They say the coordinates of P is the midpoint of BC. So if it's the midpoint, we go to our formula sheet and get the midpoint, the formula for the midpoint. Remember, the formula for the midpoint is the M should be that bigger M, then it should be 7. We start with the X. It's 7 plus 6. So remember, we add, it's 7 plus 6 all divided by 2. The other one is going to be a 0, plus minus 4. So it will be 0 minus 4 over 2. So my midpoint of that line will be 13 over 2. The other one will be a negative 2. So I can check. 13 over 2 is 6.5. So the midpoint of this can be 6.5 somewhere there. And then from there, it can be a negative 2 there. So my P value can be 13 over 2, and the other one can be a negative 2. So can you see that we have a correct answer there? So your answers must make sense, okay, in this case. So now the other question, the 1.4 says we need to get the length of AB. So length, see this word length associated with distance. So in other words, the length and the distance are the same thing. So the distance of that, so I'm going to say the distance of AB. Remember, we have a square root. So in other words, you must go to the formula sheet, back to your formula sheet, check your formula sheet, and see if we can be able to identify that formula. Remember, day before you identified all those formula, you know which one is for where you're going to use any of those formulas that we have there. So AB, so I'm looking for line AB. So it's from A to B. So from A to B, I'm starting with the 0. So it will be 0 minus 7, starting with the x value squared plus, the formula has a plus. So I said 0 minus 7. Then I'm going to say 4 minus a 0 squared. So I'm going to have square root of, so the square of 7 will be 49, and the square of 4 will be 16, and the answer will be the square root of 65. So my answer will be the square root of 65. So meaning that the length of this line is square root of 65. Right. Okay. Now, let's move on. Right. Question 2. In the diagram below, a semicircle is sketched with a tangent line touching at point Q. Now, the circle is given. It's a semicircle actually. The semicircle, right? So now we have got a line here which is a tangent touching at point Q. Point Q is given there. Now, the question says determine the equation of the semicircle. How do I get the equation of the semicircle? First of all, I have my point here. So I can use any of this point that I'm having. I'm having 1, 2, 3, 4. I can choose any of those points. Remember the equation of the circle. First I must get the radius. So in other words, to get the radius, I'm going to say x squared plus y squared equals to the radius squared. So I must first get the radius. So the radius, what is the radius? It's the line from the center of the circle to the circle. So meaning that from here to there, the length of that line is 4. The length of that line here is 4. The length of that line here is a 4. So all these are radi. So I did not need to calculate it, but just for the sake of that, let's calculate it. Let's maybe use this point to calculate and see. So the x value is 2 squared. The y value is negative 2 square root of 3 squared. It's equals to r squared. Just being naughty. I really know the equation. So there will be 4 plus, what is 4? What is 4? What is minus 2 squared? It's 4. Square root of 3 squared. It's 3. So 4 times 3 will give us a 12. So here I'm going to get a 12 r squared. So my r squared is going to be 16. Therefore, my r is going to be 4. So I have the r squared. So you can see I still get the same answer here as the one that I got. Okay, I was just being naughty there. So now, how am I going to get the equation of the semicircle? Remember, it is below the x-axis, so it must be minus. So remember, we need to write the square root. So it's r squared minus x squared. Okay, so how do I get there? So I'm going to get, I know what is my r. My r is 4. If it's squared, it becomes 16. Remember, I'm writing an equation, so it must be x and y. Okay, right. Now, the next question says we must get the length of the gradient, actually, the gradient of OQ. What do you know about OQ? I know that that line will always be perpendicular to the tangent at the point of contact. So in other words, I need the gradient of that. Look at how easy the gradient will be. I know that this is x, this is y. What is the gradient? Is the change in y over the change in x. In these circles, it is easy and straightforward. This question, everyone must get it. Easy and straightforward. Look at what I'm going to do. The gradient of OQ will be equals to, remember, it's a change in y over a change in x. So here it's 0 and 0. So it will be 0 minus this and 0 minus the x value. So how do I write the gradient? The gradient will always be, I'll take this one as it is, the y value as it is. Only do this if it's from the center. And I'm going to take the x value as it is. So that is the gradient of OQ. Because it will be, if I work it out, it will be, the gradient of OQ will be 0 minus into minus 2 square root of 3 divided by 0 minus 2, and that gives me positive 2 root 3 all over 2, negative 2. So if I work it out like this or that, so I'll have this cancels this, and the answer will be negative square root of 3. If I simplify it further, can you see we still get the same answers? So if I've got a gradient from the center, line from the center to the point of contact on the tangent, and this point is given, just take the x and divide it with the y, and then you get the final answer. Okay, simplify further if it can be simplified. Leave it like this, please. Leave it like this. So write it when they say correct to whatever decimal, then change it to decimal. But if they don't say it, just leave it as in a set form. Okay. Now the next question here, it says, continuing with that question, what do I know? I know the equation of the circle. I know the gradient of that. The gradient of that is negative square root of 3. How do I know that the gradient of that is a negative gradient? This one is going to be a positive gradient. Remember, this line is perpendicular to that. Right. So, which means, now they said, hence determine the equation of the tangent line. So, remember, equation of the tangent is nothing else but the equation of the straight line. But that straight line is a tangent, so we need to work out what the gradient of the tangent is. I know the gradient of OQ, QO, and I know that gradient is negative square root of 3. But this line here is a perpendicular line to this. So which means, what do I know about perpendicular lines? Their gradients. What about their gradients? When you multiply the two gradients, the gradient of a perpendicular line and the gradient of that radius there, so the gradient of the tangent and the gradient of the radius there, you must get negative 1. Which means that the gradient of the tangent will be nothing else. This is over 1. So we just swap it around. We put 1 on top, square root there, and we change the sign. This is negative, so this should be positive. So now we know the gradient of that, but it says it passes through the point 0 and negative 5. Easy. What do I know about 0 and negative 5? If I extend that line and there, just above my head there, so therefore that will be negative 5, which means it is the y-intercept because the x is 0. So I don't need to stress myself writing down the equation, substituting and all that. I just immediately see that that line there is, that point there is the y-intercept, which is c. I have the gradient, I have the c, so I can write the equation. So my equation will be y equals to mx plus c. My m is 1 over square root of 3. Remember, I must put an x minus a 5. I can still do it by using y1 minus y2. Y minus y1 equals to m into x minus x1, but the answer that I'm going to get will still be the same. Okay, but I want you to try it like that. So we're gonna try it by y minus y1 equals to gradient into x minus x1, where you substitute your y1 with negative 5, your x1 with a 0, and your gradient with that one. And then the answer will still give you 1 over square root of 3x minus 5. Okay, right. Interesting question. Okay, can you see that they did not use this point? They used another point there. So you see, you can use any other point as long as it's on the tangent. So they might have used that other point here. Can use any other point here, they can use any other point as long as that line is on the tangent. Because even if we use this point, we still get the same answer here. Okay, right. This next question here, every year it comes like this, and then we still struggle to do this question. That question is a free mahala max. So this we must get. It's free marks. Now, let's see. You're given x squared over 25 plus y squared over 6 equals to 1. You see, it is equals to 1. How do I get my x-intercept? Do you remember what we said we do? If I need the y-intercept and I've got the x-intercept and I've got x squared, what do? I take the 25 and take the square root of 25, and then the square root of 25 is 5. I go to my graph, I locate 5 on the x and negative 5. Remember, square root is plus or minus, so I'll have plus minus 5. So I've got a plus 5 and the minus 5 will be somewhere there. I put my crosses there. To get the y values, I'll go y equals to plus or minus. I take the 16, I say square root of 16, it's equals to plus or minus 4. I go to my diagram, I locate my 4 and minus 4, and from there I just join these points like this, and then I'll have my beautiful graph there. Okay, and that's all that we do. Then obviously I must put a 5 here. I must put a 4 here. I must put a negative 4, and I must put a 5 here and a negative 5. We realize in the diagram we don't give you these numbers, né? So we don't give you these numbers, so you must indicate them. Because when we mark this, we mark the shape, we mark that, then we also mark the x-intercept. So we mark the y-intercept, the x-intercept, and the shape. So it's 3 free marks. In this one, they even give you the bonus mark, which is determine the length of the measure axis. So the measure axis is this line here, because measure means big, minus small. So this is the line, is the longest line, measure axis, longest line on the axis. So the longest line on the axis is this one, because that one is from 4 to negative 4. This one is from negative 5 to 5. So we need to find the length of this line. So the length of that line is nothing else but 10. Okay, because remember length, this is 5, this is 5 units, this is 5 units. So remember, length doesn't have a negative. Don't say it's 0. Add minus 5 and 5. So that will be 10 units. That's a bonus mark. Okay. All right. Now let's go to trigonometry. Now in trigonometry, we're looking at 50 plus marks, but we said let's try to get up to 20 marks. Okay. Now, one of the two questions that we can get 20 marks from is this type of question where you use a calculator. We use a calculator. So most of us, mostly, what we do is we go and borrow the calculators just before we write the exam. And some calculators will be, if you borrow my calculator, you find that my calculator is in radians, and you're going to get wrong answers. So make sure that you use the calculator that you've been using in class. Okay, so, or if you know how to reset it, reset your calculator, that calculator that you have been borrowed, reset it to its original, so that then you work with degrees. Because if I put it in radians and I substitute this 38 and that 153, I'm going to get a wrong answer. You can try this. Right. So in this case, but don't do it in the exam. Now let's use this. Now I'm having sine P, so what do? I substitute 38.9. These questions we must all get, please. Then we say bracket, we say plus cos of 2 times 153.2. Please don't write them separately. Don't take a calculator and sign 38.9, you write the answer. Cos 2 times 153.2, you write the answer. No. Do it at once. Take your calculator, press sine, open bracket, 38.9 degrees, close the bracket, plus cos 2, open bracket. Obviously, when you say cos, it will open the bracket, okay? then you can just say 2 times 153.2, close bracket, and then you say equals to, and the answer that you get will be approximately 1.22. Remember, all answers must be given correct to 2 decimal places unless stated otherwise. To see that in your instruction on the question paper, go through those instructions. Okay, right. The next one, same thing. You are going to substitute the P, substitute the S. But what is the challenge here is the sec of. Because in your calculator, you do not have a sec. Okay, so you need to make a plane. What do I know about sec? It's a reciprocal of cos. So reciprocal means there must be a 1 somewhere over something. So I just first start by writing that 1 over sec and cos. Then I can substitute my P. 38.9 degrees divided by 3 plus 153.2 degrees, close bracket, extend my line there. Then you use your calculator. You see 1 over, you use a fraction button. On top you put a 1, at the bottom you put cos, open bracket, all those angles in there, close the bracket. Your answer is approximately negative 1,03. Right. Okay, and you're done. I mean, these 2 questions, mostly when we mark, it's about 5 marks. So out of 20 marks, we already have 5. And these questions are there, year in, year out, they are there. So you must learn how to do them. So can you see how they can get the 20 marks that I'm talking about? Already 5, running short of 15. I'm going to show you how we're going to get the other 15. Now, this question also, it's a free ride. I call it a free ride because then you need to understand your cast diagram. Once I understand my cast diagram, this question becomes very easy. So use the diagram to determine the following. Once they say use the diagram, it means that you must draw your own diagram. There's no diagram that has been drawn for you. You must draw your own diagram. What are we checking? We want to check if you understand your cast diagram. So if I'm going to try to draw it here. So I must first check. This is my y-axis, this is my x-axis. The cos value here, it's a negative value. So it's cos negative 3 over 5. So if I use my cast diagram, what do I know then? I'll know that the cos here is positive. All of them are positive. Sine is positive, tan is positive there. So now, what am I given? I'm given that the cos is negative, meaning that cos, my diagram cannot be in this quadrant. My diagram cannot be in this quadrant. Why? It is because cos is positive, here all are positive. So I'm left with 2 quadrants. So, but they say the beta, the angle, it's a negative, it's greater than 180. So, which means that if I'm at 180 here, my angle must be bigger than 180. So if it's bigger than 180, where does it take me? To the 3rd quadrant. You see? So which means that the 2nd quadrant will be out because they said it must take me to the 3rd quadrant. The angle must be bigger than 180. So it is a question of understanding and try to make sense out of what the information is given. So my diagram will be in this quadrant. 90 degrees there. Always join it on the x-axis. Now I need to allocate the 3 and the 5. So remember cos is adjacent. Here's my angle here. It's adjacent over hypotenuse. But what is wrong here? The sign negative must go there. It cannot go on the 5. Remember 5 is a radius. It cannot be negative. So it must go on the -3, on the -3. Obviously, it is true that that x there can be negative. So can you see now I have my -3 and 5. I'm running short of that y value. How am I going to get the y value? I use the theorem of Pythagoras. I've got the x, I've got the r. So I've got the x, I've got the r. I need the y. So x, so y squared will be equals to my r will be 5 squared minus, remember I'm taking this on that side, into minus 3 squared. So 5 squared is 25. 25 minus 9 is 16. So my y value will be plus minus 4. So out of these two, I must choose one. So I cannot choose a positive because this line here is a negative. So I'm going to choose that one as a negative 4. So which means I can now do my two activities, my two questions. Sine beta, so my sine will be opposite over hypotenuse, negative 4 over 5. My cos is going to be, oh, it's given, my cos is given, so it will be negative 3 over 5. So my answer will be negative 7 over 5. Now some I can see you're asking, where is the plus sign? Okay, the plus sign is there, but this thing is minus 3 over 5. So the negative and the positive gives me a negative. Okay, that's your final answer. Leave your answers as fractions. Don't try to get to decimals and all of that. Okay, now the sec beta plus cot beta, same principle that I'm going to use. So what is the sec of beta? How do I get the sec of beta? So the sec of beta, remember sec is an opposite of, it's a reciprocal of cos. So the cos is given, so it will be negative 5 over 3. How do I get the sine of beta? I mean, that's the cot of beta. So the cot is an opposite of tan. So if I know the tan, then I know the cot. So that will be plus into negative 3 over negative 4. Because remember, tan is going to be minus 4 over negative 3. Cot will be negative 3 over negative 4. Put equal signs there. So I'll have negative 5 over 3. Negative and negative is positive, so I still keep my positive. 3 over 4. And then I can just quickly work that one out. I think the answer will be minus 11 over 12, if I'm not mistaken. Because the LCM is going to be 12. And then we're going to have minus 11 over 12 as our final answer. Okay. All right, we are doing very well. Now this question here also, so in that question, the question that I've just done, mostly we find that it's about 7 marks. So we must get it. If we get that to 7 marks plus 5, we're already at 12. So we're running short of 8 marks. Then we'll see how to get the 8 marks there. Now this question also, it's quite an easy question. What makes it easy is that I'm only working in the first quarter. So which means first in first. So first I must divide by half. Both sides by half. If I divide by half, I get cosec 2 theta equals to, get my calculator. So I'll have 0.814 divided by half. Okay, so my answer that I'm going to get 1,628. Now I have a challenge here. If I have a cosec, I need to say shift cosec and angle, but on my calculator I do not have a cosec. So you must know your reciprocals very well. So my reciprocal for cosec is sine. So if I put sine, so I'm going to do this now. If I see a cosec, put a sine 2 theta and immediately write 1 over 1,628. Okay, so if I've got a sec, I'll immediately write cos and immediately put 1 over 6. That's the number that I'm having there. So then I can say shift sine, open bracket 1 over 1,628. You don't need to work out that 1 over 1,628. You just say shift sine 1 over 1,628. And the angle that we're going to get there is 37,89 degrees. Right? Because I need theta, I need to then divide both sides by 2. You can only do that if you are working in the first quadrant. Once you work in all the quadrants, you can't do that. You must first check where the sign is positive. In this case, I'm working in the first quadrant, so I don't have a problem. So there will be 18,95. Remember, we must write it correct to 2 decimal places. Okay. So remember, this is approximately that, and that is approximately that. Correct to 2 decimal places. So remember, we still have values there. Okay, right. Okay. So this question is about 3 marks. So I'm just counting the marks now. With 17 plus 3, I've got 20. So sorry, 12 plus 3, I've got 15. So I'm running short of 5 marks. And where am I going to get my 5 marks? Yeah, I'm going to get my 5 marks. This question here is about 7 marks, but I'm anticipating getting all the 7 marks, so I'm above 20. You see how we can plan? You must plan on how you're going to pass. So 1 minus sine squared theta. Look at this. 1 minus sine squared theta. Do you still remember the famous one? Sine squared of theta plus cos squared of theta. It's equals to the famous one. If I take this one, this side, okay, not that one. If I take this one, this side, I'll have cos squared of theta. It's equals to 1 minus sine squared of theta. Sine squared of theta. So can you see 1 minus sine squared of theta is the same as cos squared of theta. So in the place of 1 minus sine squared theta, I can put cos squared of theta minus this cos squared theta, and the answer is 0. Very simple as that. Or I can replace this one by that. So I'll have sine squared theta plus cos squared theta minus sine squared theta minus cos squared theta. Then I'm going to have a 0. Sine squared theta minus sine squared theta, cos squared theta minus cos squared theta. So the answer is 0. Now let's get to this one. This is where I can get all the 7 marks. Easy, straightforward 7 marks. Okay, now let's see what we must do here. If I've got pi, I just put 180 degrees there. Okay, so how am I going to work out this sum? Simple. First, you draw a Cartesian plane. You put your 180, you put your 360. That's all that you do. You put T, C, A, S. Right. So I've put 360 here, and then I'll say minus, that I'll say plus, that I'll say minus. Okay. So already I've got my answers. First of all, I'm going to say sine 180 plus. So 180 plus, it falls in the 3rd quadrant. In the 3rd quadrant, I do not have S. I have a T. So which means I'm going to put a negative sign of X. Done with the first part. Let's go to the second one. The sec will remain sec. I want you to put everything in the brackets. Right. Tan 180 minus. I go to 180 minus, falls in the 2nd quadrant. In the 2nd quadrant, there's no T. If there's no T, what do? I put a negative. All over. In the next one, 360 degrees, there's no sec. So, but I know sec is a French cos. So 360 minus, it's a friend to cos. So there's a cos here. So I'm just going to write it as cos sec of x. Put bracket. 180 plus, 180 plus. There's no c. So which means that it will be a negative. So it will be negative cos x. Tan 180 plus, there's a t there. So it will be positive. Done. And this is how we mark it. 1, 2, 3, 4, 5, 6. So already have 6 marks. So the last thing that you need to do is to cancel out. The second, cancel out. So what am I left with? I'm only left with what? Let's check the signs. Negative times negative is positive. Divide by negative is negative. Well, my answer will be negative. On top, I'm left with the sign of x. At the bottom, I'm left with the cos of x. So what is sine over cos? It's tangent. So it will be tan of x, which is a negative tan of x. Okay. Alright. So it's 1, 2, 3, 4, 5, 6, 7. Already I've got 7. 15 plus 7. 21. 22. So I'm done with I've done there. So up to here, my trigonometry, I already have 20 marks. So the rest of them is the bonus. It's getting to the next level. Okay. And you'll see how the bonus come about. Here is a bonus. Here's a bonus. Now the bonus is drawing the sketches. So, and that sketch, it's over 7 marks again. So can you see, you can still get up to 50 on this one. So 2 sketches are given there. I mean, two graphs are given there. They say you must draw them from 0 to 360. We will always give you the Cartesian plane, because we know once we don't give the Cartesian plane, you will get some crazy graphs. Okay, right. 2 sine x. Obviously, we know the original sine graph, but I can use a calculator. So if I use my calculator, I'm going to use, so if there's no number there, you see there's no number there, I can use the 90, 180, 270, and 360. So let me use that. The sign of 0 is 0. So 2 times 0 is going to be a 0. So my graph starts there. So you can use a calculator. Sine of 90 is 1, but 1 times 2 will give us a 2. Sine of 180 is 0. So 2 times 0 will be 0. Sine of 270 is negative 1. Negative 1 times 2 is negative 2. Sine of 360 is 0, and then we have a 0. Then from there, I'll just join all these. Join this one, and join that. I get my lovely graph. There's no child without a name. So the name of this child is K. You can just write K of X, or K. Right, or F, or K, but this one is K. Right, this graph here. So let's get to the next one. The next one is the cos graph, is the general graph. The cos of 0 is 1. The cos of 90 is 0. The cos of 270 is negative 1. Sorry, negative 1. Oh, sorry. The cos of 180 there is negative 1. The cos of 270 there is going to be a 0. And the cos of 360 will be a 1. So in other words, I'm going to join this, and then I'm going to have my graph. And my graph there will be the graph of H. See? 7 marks done. Calculator. There. Just put it on a calculator and then you get that. Okay. Now you can see I'm right, because the sine and the cos are both positive in the first quadrant. Remember, this is the first quadrant. This is the second quadrant. The sine is positive, cos is negative. In the third quadrant, both of them are negative. That's why they're below the x-axis. In the fourth quadrant, the cos is positive and the sine is negative. You can see these are quadrants. First quadrant, second quadrant, third quadrant, and the fourth quadrant. So I know I'm correct according to those graphs that have been given. All right. How high is the graph here? It's at 2. How low is that graph? It's at -2. How high is this graph here? It's 1. And that one is -1. How low is -1? Okay. The next questions I think we'll be dealing with that. Given those two graphs again, write down the range of K. So the range is how high the graph is. Yes, the graph, how high is the graph and how low is the graph. That is the range. The amplitude will be 2, but the range, don't confuse the range with the amplitude. The amplitude is the distance between the x-axis and the graph there. But the range will be how high and how low. So in other words, how high and how low. So our graph there, so range, we are talking the y value. How high it will be at 2, how low it will be at -2. So that's how we write it. Okay, make sure that you write down the correct notation. Or I can write y is an element of square bracket -2, square bracket again 2. So square bracket means those two values are included because that part is also included. Write down the period of h, period of the cos graph and the sine graph, it's always 360. So the period of this graph, mostly we make a lot of mistakes there. We write x equals to that or y equals to that, I don't know, or we write an interval, we write 0 and 360. It's incorrect. The period is 360. And this mark is an accuracy mark. So in other words, you must not write any other thing. You can just write period, it's equals to 360. Don't write any other thing or greater or equals to. Just write 360. Okay. Right. Now, can you see that the marks that we already got is about 30 marks if I include the graph. So it's about 28, and the range and the domain, those are easy ones. So it's about 30 marks. So can you see, if you practice well, and if you can get 3 question papers and practice well, I mean, we'll be able to get all this full marks. Now, let's go to the geometry. Euclidean geometry. Euclidean geometry, I said you must get your examination guideline. Because that gives you the acceptable reasons and the theorems, how to write those theorems, like in this one. Angle at center of the circle, it's twice. Angle at the circumference. Okay, so that is the theorem that says, if I've got the angle that is formed at the center, it's twice that angle that is formed there. So if I've got A, B, C, and O, the angle AOC, it's twice the angle that is formed at the circumference, or at the circle. Right. Opposite interior angles of a cyclic quad, what do we have? We are having a cyclic quad. Then with the cyclic quad, we're talking about opposite angles of a cyclic quad. That angle here plus that angle there must give us how much? 180 degrees. So we can just say they are supplementary. Okay, right. Right, they're supplementary. So supplementary means that they add up to 180 degrees. So in geometry, these are things that you need to get. As I said, get your examination guideline. Okay, activities on Euclidean geometry. This Euclidean geometry is very, very, very easy. As long as you have the acceptable reasons, this is very easy. Now, if I check this, for instance, in the diagram, O is the center, so I've got a center. So what should I look for? Angle at center. Okay, right. PQRS is a cyclic quad. So I'm already given that PQRS is a cyclic quad. What do I know? Opposite angles of a cyclic quad are supplementary. And exterior angle of a cyclic quad. So O1 here, it's angle at the center. So it will be twice that angle here. So can you see? So I already know that O1 will be twice 53. and that will be 106. Then you write the correct reasons there, which is angle at center, the one that we're talking about now. Angle at center, it's twice angle at the circle or circumference. So you must write the correct reason. Very important that you write the correct reason. So you'll get 1 mark for that. You'll get 1 mark for the correct reason. If you don't write the correct reason, then you lose the mark. And we don't want you to lose that mark when you have an exam guideline. Okay. Now, B, S2. So we already know that this is 106. S2 is the angle. Can you see that angle is outside? Outside the cyclic quad. So this angle here will be the same as that angle. It's an exterior angle. So this one will be 53 degrees. So we can then write the reason, correct reason is exterior angle of a cyclic quad. We already know what you're talking about here, okay? Exterior angle of a cyclic quad equals to the opposite interior angle. All right. Let's look at P, the whole of angle. Now we know this is 53. Work on the sketch also. Use the colors to work on the sketch. You'll have a answer book. So in that answer book, work on the sketch. You use the colors. And once you work on the sketch, then we are able to can also mark what you have written on the sketch. Because sometimes you forget to write the angle there, and then you're excited that you got it right. Then you forget. So put it on the sketch. You also mark it from the sketch. So this is 53. So you are having two parallel lines. Can you see that the parallel lines are given? So that angle here and that angle here will be the same, will be equal. So which means that P will be 53 also. What is the reason? Corresponding angles. Once you write corresponding angles only without parallel lines, we give you a 0 for the reason. So you must write down the parallel lines. Always, always. Right? Corresponding angles, alternate angles, write down the reason. Okay. Write down the reason and also include the parallel lines. Very important. That is very, very, very important. Because some of you get it right, they write corresponding angles, they don't write parallel lines, we mark them wrong. Okay. Right? Here's another one. It seems like it is a very, 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 very challenging question, but it's so easy. You check with me. Now, you are given that this line is a tangent. What do I know about the tangent and the chord? There's an angle that is formed somewhere there. Already you see, I can have answers. So I can work out the sketch without looking at the questions. So already I know that this angle and that angle are equal. This is 55. Is it asked somewhere? Yes, D1. Oh, I already know. D1 is how much? 55. What is the reason? Tan chord theorem. Can I get F3? F3. So I see there's a parallel line here. There's a line here, and that line is parallel to that. Oh, I have my Z or my N, whatever you want to call it. So I have this and that. So that angle here is alternating to that. So my F3 is already 53. The reason being, there are alternate angles. What am I forgetting? To include the parallel line. Very, very, very important. I'm noting this again, that you know. Okay. All right. Now, the next question on analytical, on Euclidean geometry is that easy question that we always get and then we don't get it right. This line is parallel to that. Already, what do I know? This line over there is the same as this line over there. Okay. So they say write down the length of, they say the length of this POR is 20. Now write down the length of that. This is the center of the circle. Write down the length of that. So obviously the length of that will be 10 centimeters. As simple as that. That's the mark that we must get. So don't just look at the diagram and then you don't go to the questions and then you just stop because you see the diagram, you have never seen it before. No. Sit with the reason. What is the magnitude? Magnitude means the size of the angle. Okay. Right. So what is the size of this angle POR? Obviously that is 90, and they want the reason. This is the diameter, it subtends that 90 degrees. So POR is 90 degrees, and the reason will be angle in a semicircle, or we can say angle at center, it's twice that angle because this is 180 degrees. So it's angle at center, we can use that. Or we can say angle subtended by the diameter. Okay? Right, those are the reasons that we can put in there. Okay? Determine the length of PQ. Already PQ. So I'm given that this length here is 12. That whole length there is 20. This angle is 90. What type of a triangle is this? Right angle triangle. In a right angle triangle, if I've got two sides, I can get what? I can get the third side by using the theorem of Pythagoras. So meaning that I can have PQ squared is equals to PR squared minus QR squared. So PQ squared will be the same as the length of the hypotenuse minus the other side. So I'll have PR is 20 squared minus QR is 12 squared. So 400 minus 144 will give us 256. And PQ will now be equals to 16. So this length here is 16 centimeters. Right, please write units as they've been given. Okay, the last but one question. QS, where is QS? QS is given as 2 and OQ. OQ, right? It's given as 5. Right. Now, QS is this one, yes. So, and OQ, all right. Now they say, state a reason, determine the length of SV, and we must also state the reason for that. Now, obviously, then what should I do? I must first write down the ratio. My ratio is going to be SV over OR. It's equals to, I know OR is going to be 10. So it's equals to QS over OQ. So you can check this. So as this one over that, it's equals to SB over OR. And that is similar. Because this triangle here is similar to that triangle. Then if the two triangles are similar, therefore we can then write that way. Okay. It's also through the proportionality that we have from similarity. Okay, so those triangles here, the reason that I'm going to put is this triangle here, it's similar to the bigger triangle. And if they're similar, then I can use the proportion for similarity. Okay, so in this case, what is my SV? I don't know. What is my OR? It's 10. And this is 2 over 5. Therefore, SV, if I cross multiply and divide by 5, my SV will be 4 centimeters. Okay. All right. So, okay, my reason, as I said, it will be this triangle here, it's similar to that triangle there. Okay. Right, because if I write proportionality for those triangles, I will get that proportionality will be correct. Okay. Now, circles, angles, and angular movement. We're not going to waste time on this one because I know with this one we have a lot of formula, so we need to work on the formula. The formula is given, so there's no problem with that. The only challenge in this topic is conversions. If you don't know your conversions, then you're always going to get wrong answers. So you must know how to convert. Right. In this case, we are having a CD. It moves on the track from B to A. The radius of the CD, therefore, the radius is given as 5. Put it here. Figure 1 represents the crack. There's a crack on the CD. There's an angle there that is formed, which is how much? 60 degrees. The first question says, calculate the arc length So you go to your formula sheet and check which formula to use for arc length. Now the formula for arc length, first, what do I need to do? I need to change the degrees to radians. Remember, the formula for arc length is S r times theta. But the theta must be in radians. Angle must be in radians. So what should I do? I'll change the 60 to radians. So how do I change my 60 degrees to radians? That's what I wanted to explain when I explain the formula. So that will be, I multiply this one by pi over 180 degrees. So when you change degrees to radians, you always multiply by pi over the degrees, 180 degrees. So this will give me pi over 3 radians. If I want to change radians to degrees, then I'll multiply by the degrees over pi, which is 180 degrees over pi. Remember what I'm doing here. I said pi is 108. So I'm just multiplying by 1 actually. So I'm just saying 180 degrees divided by 180 degrees. But because for the radians, we need the pi as 3.14, then we can get the radius. Okay, I hope you understand it. Now, so now I have this, so I can substitute. What is my radius? 5. What is my angle in radians? It's going to be pi over 3 radians. And then I multiply this, I get 5 pi over 3. You can leave your answer like that. Well, don't go to decimals and stuff like that. Just leave your answer in that form, okay? Okay, because sometimes you mess up, you know, you take that pi, you divide it, you say 5 divided by 3 pi, and then you get a wrong thing. So just leave your answer like that. Okay, right. Even on the calculator, if you put it on calculator, it gives you that. If you want decimal, then you go to S to D. Okay, so don't do that. Right. Okay. Now, to determine the area, you go to your formula sheet, you look for the formula for the area. Remember now you have got 5 here, centimeters. We only need the area, but you must read the question. Because they just need the area formed by the crack. Sometimes they can ask you the area of the hole of the part of the CD which is not cracked. So in this case, they're asking for the part that is cracked. So you must read the question. You must not just go to the formula and then substitute what is given there. So you must also check the question. Now, determine the area formed by the crack. So what is the formula for the area? You go to your formula sheet. You use the formula of where we have values that have been given. Don't go and use the formula for, quickly go and use the formula for RS over 2. The S was not given. The arc length was not given. You calculated it. You can still use that formula if you're confident in terms of, you're sure, very sure that your first question you got it right. But basically go and use the formula of things that have been given. Remember, theta was given at 60 degrees. We have already changed that theta to 3 pi over 3. Okay, so I just go and substitute. My R is 5 squared. My angle is pi over 3, all divided by 2. Remember, in second angles in a movement, we are using the radians. So here it's 25. I think the answer there will be 25 over 6 pi. Leave your answer like that. So if I want to be smart and I use that RS over 2, so which means, copy the formula correctly, which means my R is 5, but my S that I got was 5 pi over 3. That is divided by 2. So my answer will still be the same, 25 pi all over 6. So I'll still get the same answer. Okay, but I prefer that we use the one where all the values have been given, so that when you have made a mistake on the S, then you don't get punished in the next one. Okay, right. You need to get it right. Now with this one, you're given the tapping washing machine with a diameter. The biggest issue is these things here. The question, read the question and read it again and check what is required from you. The angular velocity. So remember, angular velocity is the omega, which is 2 pi n. But one thing that I need to do, there I'm given 1,800 revolutions per minute, but here they want it per second. Can you see where we make mistakes? So it means that my 1,800 must be divided by 16. Must be divided by 60, and I think that will give us 30. Okay, so it means that my number of revolutions will be 30 revolutions per second now. So which means I'm going to substitute now 2 pi multiplied by 30. Then the answer will be 60 pi. So leave it like that. Don't try to multiply the 60 with the pi and get decimals. That's what they mean. So the biggest issue here is there, right? Taking this minutes to seconds. Okay, right. The next one, same question, but now they want us to get the circumferential velocity. So with the circumferential velocity, I know the formula is going to be v velocity equals to pi d n. So now here they wanted meters per second. Can you see that 420 was given as millimeters, but here they wanted meters per second. So in other words, my revolutions will be 30 also, because everything must be in seconds. So pi will remain. My diameter now, I'm going to, for me to take this to meters, I must divide this by 1,000. You must know your conversions, very important. So I'll get 0,42. So I'll get 0,42. This is now in meters. The revolutions there must be 30. Then my answer is going to be, if I work this one out, 63 over 5 pi, then is meters per second. Okay, all right. So please check your conversions. It's very important that you understand your conversions. Okay, here now they need the length of us, US. This is the height. What type of height is that? Is the minor height. Is that a small height that we have there? So we've got the height in the major segment and height in the minor segment. So that height, so we've got two of the height there. So I'm going to call them height 1, height 2. So how am I going to get that height? So to get that height, I must write down my formula for dh plus x squared is equals to 0. Right? So for me to get the height of that, so I'm going to substitute that. Then my diameter is going to be 42. Why 42? Because now I need my answer in centimeters. Right? My height, I don't know. My x squared, I know, because then it's going to be 250. Remember, I'm dividing that by 10 to get to centimeters. So now that equals to 0. Then I'm going to get h squared minus 168h plus 625, it's equals to 0. Then my h, if I use my calculator and quadratic formula, then my height is going to be 164.19, or the other height will be 3.81. So I choose that height here. Which one do I take? H1. which is going to be that height. So therefore my height is going to be 3.81 in centimeters. Okay, I can still work it in millimeters, but then at the end I must change it to centimeters. I must know how to do that. So the conversions are very, very, very important. Okay, the last question that I'm going to do now, it's on the area. That is the one that I'm talking about in terms of the two formulae that we need to use. We need to read the question also. Now the question says the irregular shape. Remember, this is the area of the irregular shape. So the area of the irregular shape, we're given the ordinates, right? And 2. They are in meters. Again, here the conversions is very, very important, because some of the conversion, some of the ordinates might be given as millimeters, and then you haven't seen it, and then you just mix millimeters and meters, and some in centimeters. So you must first check that the coordinates are given in the same unit. This one, it's 16. The whole length from here to there is 16. How many parts do we have? 1, 2, 3, 4. So you must write down the number of parts that we are having, so that you are able to check if that is given as 16 the whole. So I must divide this by 4 to get my A. So it means that my A is going to be 4. So first I must write down the formula. So the formula for the area of the irregular shape, copy the formula correctly. So the first formula is A into, so it's O1 plus ON all over 2 plus O2 plus O3 plus dot 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 O n minus 1. Now we see when you're substituting, you put n minus 1 and then you put the value of n, and then from there you say minus 1. No, don't do that. Look at how we substitute. First of all, the area has been given. So I'm writing the area of 73.6 square meters. That's what is given. The A, I got it there. It's 4. My O1, 6.2. Plus my ON. Remember, ON is the last one. So it's plus 2 all over 2. There's the only one that we're dividing by 2. Then O2, we write it as it is. It's X. O3, we write it as it is. It's 5,1. The last one will be 4,9. Please don't go and add the 2 because it's already done there. That's the mistake that we always do. Then we are going to divide both sides by 4. We get 18,4. And then we're going to have, inside there, we're going to have, I think, 14,1 plus the x. Then we can just transpose that. X will be equals to 4,3 meters. And that's how we get the final answer. Okay, so that formula. You can also use the other formula for M1, M2, M3, but make sure that you understand. When you're practicing, practice both formulae so that you don't make mistakes when the other one you forgot what to do. So this is how we do that question. The area is given, we need the x. Sometimes the x is given, we need the area. So make sure you understand the question first before you do it. Okay. With that, I'd like to say good luck to tomorrow on your paper. Please go, so on Monday. Paper 2, please go and practice. At least try to practice 3 or 4 question papers. Make sure that you understand everything. Make sure that the formula sheet you understand, because you have got lots and lots of marks that comes from the formula sheets. Because when you give us the correct formula, we give you a mark. When you substitute correctly into the correct formula, we give you a mark. So these are just free marks that you must get. So if you know your formula sheet, the formula there, make sure you use correct formula in the sums that are going to have. The measurement, you're also going to have questions on the measurement. Make sure that you go and practice them. And with that, good luck with your exams. Thank you.